National Electrical Code Article 300.3 C2 addresses the use of non-metallic sheathed cable, commonly known as Romex, in metal buildings. This section provides an exception to the general rule that might otherwise require the use of conduit in such structures. However, this exception is very specific and applies only under certain conditions. The first key condition is that the building in question must not be required to comply with Article 501 of the National Electrical Code. Article 501 specifically addresses hazardous classified locations, areas where flammable gases, vapors, liquids, or combustible dusts are present, posing a risk of fire or explosion. These locations require more robust wiring methods to minimize the risk of ignition. Since a church building typically does not fall under this classification, this condition is likely met. If the building is not classified as a hazardous location, Article 300.3 C2 permits the use of non-metallic sheathed cable within the framed walls of the metal building, provided that specific measures are taken to protect the cable. The National Electrical Code requires that the cable be run in a metal raceway or cable tray. This raceway or cable tray must be securely attached to the building structure. The purpose of the raceway or cable tray is to provide a degree of physical protection to the Romex cable. Metal raceways, such as electrical metallic tubing or intermediate metal conduit, offer substantial protection against impacts, abrasion, and other forms of physical damage. Cable trays, which are typically open, ladder-like structures, can also provide protection, especially when equipped with covers. The metal raceway or cable tray must also provide effective protection against physical damage. This means that the raceway or cable tray must be robust enough to withstand the types of physical stresses that it is likely to encounter in its environment. For example, in an area where there is a risk of heavy impacts, a more substantial raceway, such as rigid metal conduit, may be required. In addition to physical protection, the National Electrical Code also emphasizes the importance of proper grounding. The metal raceway or cable tray must be grounded in accordance with Article 250 of the National Electrical Code. Grounding ensures that if a fault occurs, such as a wire coming into contact with the metal raceway, a low impedance path is provided for the fault current to flow back to the source. This will cause the overcurrent protective device, such as a circuit breaker or fuse, to trip, quickly de-energizing the circuit and reducing the risk of electrical shock or fire. Article 250 of the National Electrical Code provides detailed requirements for grounding electrical systems, including the sizing of grounding conductors, the methods of connecting to ground, and the types of grounding electrodes that are permitted. The National Electrical Code also requires the Romex cable to be secured within the raceway or cable tray to prevent movement. This is important for several reasons. Firstly, it prevents the cable from rubbing against the edges of the raceway or cable tray, which could damage the cable's insulation over time. Secondly, it prevents the cable from being pulled or stressed, which could damage the conductors inside. There are various ways to secure the cable, such as using cable ties or clamps. The specific method will depend on the type of raceway or cable tray being used and the size and type of cable. The raceway or cable tray must be installed in accordance with the applicable building codes and the manufacturer's instructions. Building codes may specify requirements for the installation of electrical systems, such as the height at which raceways must be mounted, the spacing between supports, and the methods of penetrating walls and floors. The manufacturer's instructions will provide specific guidance on how to install a raceway or cable tray in a safe and effective manner. This includes information on the proper way to assemble the components, the torque to apply to fasteners, and the recommended spacing between supports. It's important to note that this exception in Article 300.3 C2 applies only to the use of Romex within the framed walls of the metal building. It does not cover the use of Romex in exposed or concealed locations outside of the framed walls. In such locations, conduit is generally required by the National Electrical Code to provide adequate physical protection. In summary, if the metal building is not classified as a hazardous location under Article 501, Romex can be used within framed walls if it is run within a securely attached grounded metal raceway or cable tray that provides effective physical protection, and if the cable is properly secured within the raceway or cable tray, while also adhering to applicable building codes and manufacturer's instructions. While the National Electrical Code may permit the use of Romex in framed walls under these specific conditions, it's always prudent to consult with a qualified electrician. They can assess the specific circumstances of the installation and ensure compliance with all applicable codes and safety standards. They can also identify any potential hazards or concerns that may not be immediately apparent. They can also provide guidance on the selection of appropriate materials and methods for the installation. Ignoring the advice of a qualified electrician could result in a non-compliant installation, which could lead to safety hazards, property damage, or legal liabilities. It is always a good idea to err on the side of caution when it comes to electrical safety. Some additional considerations include, firstly, local amendments to the National Electrical Code. Many jurisdictions adopt the National Electrical Code but then make amendments to it to address local conditions or concerns. These amendments can vary widely from one jurisdiction to another, so it's important to be aware of any local amendments that may apply to the installation. Your local building department or electrical inspector can provide information on any local amendments that are in effect. Secondly, future changes to the building. If there are any plans to modify or expand the building in the future, it's important to consider how these changes might affect the electrical system. For example, if the building is later converted into a hazardous location, the wiring may need to be upgraded to comply with Article 501 of the National Electrical Code. Thirdly, insurance requirements. Your insurance company may have specific requirements for the electrical system in your building. These requirements may be more stringent than the National Electrical Code or local building codes. It's important to check with your insurance company to ensure that the installation meets their requirements. Fourthly, best practices. Even if the National Electrical Code permits the use of Romex in framed walls under certain conditions, there may be situations where it is not the best practice. For example, if the building is located in an area with a high risk of rodents, it may be preferable to use conduit, as rodents can chew through Romex cable. The decision of whether or not to use Romex in framed walls should be based on a careful assessment of all the relevant factors, including the National Electrical Code, local building codes, insurance requirements, and best practices. A qualified electrician can help you make this decision. Now, let's consider some specific scenarios that might arise during the installation of Romex in framed walls of a metal building. Scenario 1. Running Romex through metal studs. When running Romex through metal studs, it is essential to use grommets or bushings to protect the cable from abrasion. Metal studs have sharp edges that can damage the cable's insulation over time, leading to shorts or ground faults. Grommets and bushings are typically made of plastic or rubber and are designed to fit snugly into the holes in the studs, providing a smooth, rounded surface for the cable to pass through. Scenario 2. Securing Romex to the framing. The National Electrical Code requires that Romex cable be secured to the framing at intervals not exceeding 4½ feet and within 12 inches of every box or footing. This helps to prevent the cable from sagging or being pulled, which could damage the conductors or connections. Cable staples or cable ties can be used to secure the cable to the framing. Care should be taken not to over-tighten the staples or ties, as this could damage the cable's insulation. Scenario 3. Protecting Romex from physical damage. In areas where the Romex cable is exposed to physical damage, it must be protected by a conduit or other suitable means. For example, if the cable is running along the floor or near a doorway, it should be protected by a section of conduit. The conduit should be securely attached to the framing and should extend far enough to protect the cable from any potential impacts. Scenario 4. Grounding metal boxes. Metal electrical boxes must be grounded in accordance with Article 250 of the National Electrical Code. This can be accomplished by connecting a grounding conductor to the grounding screw inside the box or by using a self-grounding box. Self-grounding boxes have a special design that allows them to make direct contact with the metal framing, providing a grounding path. Scenario 5. Protecting Romex in damp or wet locations. Romex cable is not suitable for use in damp or wet locations. In such locations, a different type of cable, such as Type UF cable, must be used. Type UF cable is specifically designed for underground and wet locations and is resistant to moisture and corrosion. Article 334 of the National Electrical Code covers non-metallic sheathed cable, types NM, NMC, and NMS. This article provides detailed requirements for the use of these cables, including the types of applications in which they are permitted, the methods of installation, and the requirements for protection against physical damage. Section 334.10 of the National Electrical Code specifies the uses permitted for Type NM cable. Type NM cable is permitted for both exposed and concealed work in normally dry locations. It is not permitted in damp or wet locations or where exposed to corrosive fumes or vapors. Section 334.12 of the National Electrical Code specifies the uses not permitted for Type NM cable. Type NM cable is not permitted in the following locations: firstly, in damp or wet locations; secondly, where exposed to corrosive fumes or vapors; thirdly, embedded in concrete masonry or plaster; fourthly, in shallow chase and masonry, concrete or plaster and covered with plaster, concrete or similar finish; fifthly, in hazardous classified locations; sixthly, where exposed to physical damage. Section 334.15 of the National Electrical Code specifies the supports for Type NM cable. Type NM cable must be secured to the building structure by staples, cable ties, straps, hangers, or similar fittings designed and installed so as not to damage the cable. The cable must be secured within 12 inches of every box, cabinet, or fitting and at intervals not exceeding 4 1/2 feet along the run. Section 334.17 of the National Electrical Code specifies the through or parallel to framing members. Type NM cable must be protected from physical damage where it passes through metal framing members by bushings or grommets securely fastened in the opening. Where cables run parallel to framing members, such as joists, rafters, or studs, the cable must be so secured that the nearest edge of the cable is not less than 1 1/4 inches from the nearest edge of the framing member where nails or screws are likely to penetrate. Where this distance cannot be maintained, the cable must be protected from penetration by steel nail plates or bushings. Section 334.23 of the National Electrical Code covers devices of insulating material. Boxes, fittings, and conduit bodies of insulating material must be listed. Section 334.24 of the National Electrical Code covers boxes and fittings where cables enter a box, fitting, or conduit body. They must be protected from abrasion, and a list of fitting or box designed for the purpose must be used. Section 334.30 of the National Electrical Code covers exposed work. In exposed work, except as provided in 300.11. A. The cable must closely follow the surface of the building finish or of running boards. The National Electrical Code also addresses the ampacity of conductors. The ampacity of a conductor is the maximum current, in amps, that the conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the size of the conductor, the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. The National Electrical Code provides tables that list the ampacities of various types of conductors under different conditions. These tables are found in Article 310 of the National Electrical Code. It is important to select conductors with adequate ampacity for the intended load. If the conductors are too small, they could overheat and cause a fire. The National Electrical Code also provides requirements for overcurrent protection. Overcurrent protection is the protection of electrical circuits from excessive current, which could cause overheating, damage to equipment, or a fire. Overcurrent protection is provided by circuit breakers and fuses. Circuit breakers are devices that automatically interrupt the flow of current when a fault occurs. Fuses are devices that contain a fusible link that melts and interrupts the flow of current when a fault occurs. The National Electrical Code requires that overcurrent protection be provided for all electrical circuits. The size of the overcurrent protection device must be matched to the ampacity of the conductors being protected. If the overcurrent protection device is too large, it will not provide adequate protection. If the overcurrent protection device is too small, it will trip unnecessarily. In addition to the requirements for ampacity and overcurrent protection, the National Electrical Code also provides requirements for grounding. Grounding is the connection of electrical equipment to the earth. Grounding is intended to provide a low impedance path for fault current to flow back to the source, which will cause the overcurrent protection device to trip and to energize the circuit. Grounding also helps to reduce the risk of electrical shock. The National Electrical Code requires that all electrical equipment be grounded. The grounding conductor must be sized in accordance with Article 250 of the National Electrical Code. The grounding conductor must be connected to a grounding electrode, such as a ground rod or a metal water pipe. The National Electrical Code is a comprehensive set of rules and regulations for the safe installation of electrical systems. It is important to be familiar with the National Electrical Code before attempting any electrical work. If you are not familiar with the National Electrical Code, you should consult with a qualified electrician. Failure to comply with the National Electrical Code could result in serious injury or death. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before undertaking any electrical work. In summary, while Article 300.3 C.2 of the National Electrical Code provides an exception for using Romex in framed walls of metal buildings under specific conditions, a thorough understanding of the National Electrical Code, local amendments, and best practices is crucial. Always prioritize safety and consult with a qualified electrician to ensure compliance and a safe electrical installation. Remember to also consider the specific application and potential future changes to the building when making decisions about wiring methods. The use of appropriate materials, proper installation techniques, and adherence to all applicable codes are essential for a safe and reliable electrical system.